Hello everyone, we are back in HED 241 Biostatistics and Public Health, and we are looking at maybe section 5, descriptive correlations and inferential statistics. I'm going to apologize now, I have a terrible cold this morning. I'm going to try not to cough in y'all's ears, but I apologize in advance. Descriptive statistics. So descriptive statistics summarize data. An example would be, let's say you have scores on a standardized test for 500 participants. You could calculate an average score indicating how the typical individual or student scored, which is one way to summarize the data. You could also determine the range of scores from the highest to the lowest, which will indicate how much the scores varied. Descriptive statistics are going to be covered even more in Part B of the textbook. So the next section of the textbook, we're going to talk about descriptive statistics even more. Correlational statistics. We're going to talk about these even more in Part C of the textbook, but just a quick overview of them. Correlational statistics are a special subgroup of descriptive statistics. So that's why we're going to do descriptive statistics first, and we're going to come back and do correlational statistics. Their purpose is to describe the relationship between two or more variables for one group of participants. So just kind of know these general definitions right now. Let's do an example of correlational statistics. So let's suppose a researcher is interested in the predictive validity. Validity is how believable or credible a study is of a college admissions test. That would be something like the ACT or SAT. The researcher could collect the admission scores and the freshman GPAs for a group of the college students. That's what you would look at. So to determine the validity, which is the credibility, of the ACT or the SAT for predicting the GPAs, is so after you've collected from admissions all the ACT, SAT scores and the GPAs for the freshmen, you're going to use a statistic known as a correlation coefficient. Correlation coefficients range in value from 0, meaning there's no correlation, there's no relationship between the variables, to 1, a perfect correlation. So the meanings of these values and exactly what they mean and how they're used, we're going to talk about more in Part C. So right now, just kind of know what is a correlation coefficient and what is the range of correlation coefficient. Inferential statistics are tools that tell us how much confidence we have when generalizing from a sample to a population. So make sure you remember the difference between sample and population and how they are related. All right, consider a national opinion poll in which carefully drawn samples of only about 1,500 adults are used to estimate the opinions of the entire adult population in the United States. The pollster first calculates descriptive statistics, such as the percentages of respondents in favor of capital punishment and the percentage of those opposed. Having sampled, a researcher knows the results may not be accurate because the sample may not be representative. Okay, we talked about sampling last week, so think about that again. In fact, the pollster knows that there's a high probability that the results are off at least by a small amount. This is when the pollster often mentions a margin of error. A margin of error is an inferential statistic. It is reported as a warning to readers of research that random sampling may have produced errors, which should be considered when interpreting results. Okay, a little bit more on that. Okay, margin of error. A newspaper reporting that 52% of the respondents in a national poll believed the economy was improving. Okay, so 52% of people who were questioned and surveyed and polled said that 52% said the economy was improving. You'll often see a footnote in the poll indicating the margin of error was plus or minus 2.3. This means the pollster was confident that the true percentage for the whole population, so not just the sample, for the whole population, was within 2.3 percentage points of 52%. So between 49.7 to 54.3. You often see this with voting. You'll see it, when around an election, they'll say, candidate A is in the lead by 4% with a margin of error of 1.5. So that would mean that they're, if they're in the lead by 4%, they're somewhere between 5.5 and 3.5, 2.5, sorry. Somewhere like that. So from 2.5 to 5.5 is where they're really in the lead. So it's within the margin of error, which would mean that they are still in the lead. But it's kind of showing you like how far. So populations, so remember they can be large, which would be like all adults under 18 who reside in the U.S. So, there's approximately 245 million individuals over 18 who currently reside in the U.S., give or take. Population can also be small. It would be all nurses who work in a specific hospital. It could also be all MUW students. It could be, all members of a football team. It could be, anything like that. So it could be like members of a specific football team, or it could be everyone in the U.S. who plays football. So that would be kids all the way through professionals. Okay. A study in which all members of the population are included is called a census. A census is often feasible and desirable when studying small populations. For instance, a professor may choose to pre-test all students at the beginning of a course. Inferential statistics are not needed when analyzing the results of a census because there is no sampling error. The use of inferential statistics for evaluating results when sampling will be covered in Part D of the textbook. So right now, I want you to kind of know that you would not need inferential statistics with a census. Make sure you know that. And that you would need it at other times, and when those times are. Your Section 5 questions for this week's assignment, make sure you complete all of these questions. Make sure you're taking your time on your questions and working to make sure you get them correct. You're not going to get all your points if you simply just answer the question. I am taking points off for correct versus incorrect answers. It's not just a completion assignment. Make sure you have it correct. If you have questions on this lecture or on anything else, make sure you're posting them in the discussion board under this lecture. Hope everyone has a good week. Let me know if you need anything.